Our next speaker is Markus Raschke. Markus is a professor of physics and material science at the University of Colorado. His research is in the development and application of optical microscopy techniques to resolve the quantum nature of materials at an elementary level scale of its atomic constituents. In parallel, he pursues scientific interest in earth science and mineralogy with research in the Colorado Front Range, the northern Cascades of the Pacific Northwest, and the eastern margin of the Tibetan Plateau. He is an active prospector and field collector, combining his outdoor interest. He's a fellow of the Optical Society of America, the American Physical Society, the American Association for the Advancement of Science, and the Explorers Club. So, live from Seoul is Markus Raschke presenting three treasures from the Xuebaoding: Sheelite, Beryl and Cassiterite.
All right. Good afternoon, everyone. So it's a great pleasure to be here. And really, I want to thank Julian and Bruce and Brittany and others for putting this great program together and speak. And I really want to second Julian and thanking Brian for this amazing IT technology. So I'll be talking from Korea to Kelso due to conflicting travel schedule, and I really regret that I missed this meeting, and I really want to shout out to the many friends in the audience from the Pacific Northwest, and some of us had the chance to catch up earlier this summer during my annual visit, actually, to Pacific Northwest National Lab. So I will talk about crystal habits. And specifically really about this enigmatic locality. And this is known in China since the 1950s and internationally since the 80s, primarily for the really largest gem quality Sheelites discovered at the locality, the amazing Beryl and Cassiterites occurring really co-genetically. And we have been working on the mineralization of Xuebaoding now for more than 5 years, and this has been really the first systematic approach, which after some preliminary earlier work from scientists in China, and then really with a number of people, both in Europe and the US and in China, I have been putting together a team where we started really the first systematic exploration of this locality. With a local graduate student I was advising, the only really known Westerner who visited this locality before was Bernd Ottens, who in the persistent rain and fog in Sichuan has had a chance to have a glimpse at this locality. And so in the context of actually this meeting, I want to talk actually about two adventure stories. One relates to the tabular habit. This is a very prominent locality for these tabular habits of these Beryl. And we want to understand better the crystal chemistry, and especially the question whether it is due to environmental conditions or during crystal growth or crystal chemistry. And the other is another very peculiar phenomenon, and this is that there were, for those who have seen the Sheelite from the locality, there were often two types of habits, and they were always labeled as coming generically from Xuebaoding or often Pingwu, which is a larger town further east of the locality. And the question was really, are they coming from the same locality, or are these actually different localities? And given that all the mining at this locality is from artisanal miners, this has been also a ongoing question about where actually is really the Xuebaoding locality, and I will allude you to all this. So as Julia was already saying, my Monday through Friday job is in laser labs, and I do mountaineering, mineral prospecting on weekends, and so then eventually those who know me, eventually I converge some of these activities to really do research in mineralogy and earth sciences. So here are really now the three primary minerals which occur co-genetically, and this is itself interesting because beryl you typically associate more with a pegmatite occurrence, cassiterite and Sheelite, or with a Greisen type deposit. The deposit is of a Greisen type, and these minerals occur together, and all three in absolute stunning gem quality. And the beryl in a significant size. The beryl rarely is aquamarine. We'll get back to that question actually. And really these outstanding Sheelites, this impressive size and of crystal quality, and always, as you can see in these images, on a muscovite matrix. And so you probably have seen one or the other of these in museums and collections. So what we're doing in this talk is really we are putting the mountain under the microscope. I should say the elevation you see actually, and we'll get to this point also, this is the eastern margin of the Tibetan Plateau out of Sichuan province, and the little Xuebaoding, this peak looking up there, is 5,400 meters. Locality is literally on top of Mount Rainier between 5,050 and 5,400 meters. And the student and I visited this locality at several occasions, and we'll talk about this, and then we put the mountain under the microscope. And so studying in particular then in small scale veinlets with higher and higher spatial resolution, the beryl crystals, the crystal chemistry, and really down to the atomic scale characteristics of the chemical and structural characteristics of these tabular beryl to try to answer some of these fundamental questions. What draws me in this area is really an amazing landscape. The largest mountain, Minyakonga, this rises to 7,500 meters. This is essentially 2 times the height of Mount Adams. And we went there not only in the summer, but also in the winter, and I will highlight some of that. And then you find actually from summer tourists some of the detritus from the summer trips in this low oxygen environment. So let me give you a little background on the large scale occurrence of the deposit. So here is Sichuan Basin with Chengdu. The locality is right here at the eastern margin of the plateau, and as many of you may know, that associated with this ongoing collision of the Indian subcontinent with Eurasia, which started about 50 million years ago, you have this uplift of the Tibetan Plateau. And most impressive is actually this eastern margin, where we have the contact with the Yangtze Plateau, which actually makes the bulk of the large area of China then to the east. And this is relatively stiff. And so in this collision zone, we get this extreme thrust faulting and crustal shortening, and then a seismically very active area. And that is something many of you may be familiar with, that in almost a clock set regularity, you have major earthquakes. The 2008 Wenchuan earthquake with 50,000 casualties, and 2013, this was just before we started, and literally in between our visits, we had also periodic events, some of which you've seen in the news. After a visit in 2017, literally days after, was the Zhoujiaigou earthquake. with magnitude 7. And then you probably have seen this in the news. In June 1st this year, magnitude 6 earthquake just to the south, all of this along this rupture zone of the Longmen fault. So the area at the same time has really, in fact, as a result of this faulting and tectonic activity, amazing landscape. Or I mentioned mountains rise to well over 5,000-6,000 meters. The largest peak is Minyakonga, where there is actually a great story about its first ascent. It was a book published by the Seattle Mountaineers and from U.S. mountaineers in the 30s. And you have this huge topographic relative relief. So within really on the order of tens of kilometer distance out of Chengdu, which is, despite being so far inland, only 500 meters above sea level. And then one of our area, in the area of interest here is Xuebaoding, the mountain. There's a prominent fault zone here as well, which will play a role in this talk. And then sort of our kind of base camp is in Pingwu, and this is still only a deeply cut valleys at 870 meters. So the vertical relief is just astounding in this area, and is actually one which I should say, speaking the Pacific Northwest rivals, actually exceeds the Pacific Northwest. So the mountain after which the locality sort of is named is this peak Xuebaoding. This actually had also in the Buddhist culture some significance. In fact, and this is why also this locality is very well known in China among mineral collectors in the context of these three treasures. So there is the three minerals, and this relates to three and as a key number of some of the Buddhist culture in this area, where there is sort of a large procession or Buddhist monks hike around this mountain in a fairly large area to different temples, most of which were actually destroyed during the Cultural Revolution, and we occasionally come across in some of the remote valleys across ruins of former Buddhist temples. This has become a major tourist attraction there with these travertine lakes. And the reason why the locality was actually named is because there's a lot of confusion actually about this complex topography. Many of these mountains were not climbed before the 1980s, before China opened up. It was Russian and Japanese mountaineering teams. And there is actually quite a significant geographic distance between the mountain Xuebaoding proper and a slightly smaller one, which is still some 15 kilometers away. But this is actually the one where, if at all, the locality is more closely associated with. So there has been a lot of confusion, even among the local villagers who, in this literally lost in this complex topography, where many miners actually think that the mountain behind their locality is Xuebaoding, but in fact it's the little Xuebaoding. This confusion was also among Japanese mountaineers, which actually ascended little Xuebaoding instead of Xuebaoding first. So geologically, the deposit occurs actually associated with a granitic intrusion into a marble schist layer. And what you see here, these are actually tailings, the white slope sites, and the main occurrence is actually in this band here near a contact between the granite below and then within a marble layer below the schist. And you do see from the locality, you do see the mountain Little Xuebaoding and not the main peak. So the typical course of events is to even get close to the place starts typically in cramped hotel rooms where we're sorting our gear. earthquakes is not the only natural hazard because of this intense rainfall. This is really where you get the cloud accumulation all from either India or the Pacific, and you have torrential rain all through the summer. So this is not unusual that we were helping shoveling and clearing the roadside to even get to the village closest to from where we would start to ascend to the locality. Roads washed out on a routine basis. This is an area with the globally highest erosion rate in these deeply cut valleys, and landslides are common. So this is actually my graduate student, and so there's nothing left here after this major landslide. You see the first floor of this building is completely covered in this debris flow. If you want to get a flavor of what happens when Rainier breaks out again, then you can actually get a sense. So then finally we get to the village, 1,400 meters, and then we'll go up from there. So what you picture, in fact, about the approach and also how the artisanal miners are working the locality, you can picture really the Cascades in the 19th century. You actually use a horse train and pack this up, 1,400 meters, and you just go. Now we're at 1,000 meters higher, 2,400. We'll get above tree line, 3,400, and then at the locality at 1,450. This is where we set up the tent. And this is what it typically looks like. I will show you photos, the rare occasions when the sun breaks through. You're out of the fog in persistent clouds. This is not the representative days. So we may not have more than 1 out of 5 days where there is actually the weather where we could actually see the locality. Most of the time, I was literally GPS navigating my way around there. But it does occur. The sun comes out, and you're looking here now towards Seattle. This is down the mountains. This is at the edge of the plateau, right? All of here would be flat, and the tall mountains would be looking west. So there are tent sites where the miners set up, and then from there they work in small pits and in part actually also larger by now underground workings, the locality. And what the primary goal is actually that they mine the Sheelite for the ore. The crystal pockets are sparse, and this is occasionally the windfall when they find larger crystals, which supplements the income. But the primary economic driver is actually the artisanal mining for Sheelite ore, which gets channeled into complex trajectories into China's tungsten industry. There's a huge amount of quartz associated with the deposit, which is largely left on the mountain, because economically, given the horse train, which takes a whole day up and down, including a number of other hazards, nobody takes the quartz down. So if you need a quartz crystal locality, there it is, and some are actually stunning quality. And those you see rarely in collections. So you're exploring this area, and we'll sample. That's sort of the main thing. What the main idea was that we would be able to collect crystals and material in situ, and especially material which the miners typically not bring down, which is the hosting rock environment and really understanding the association of the crystallized crystals with the vein structure and really the entire geologic context. So this is so most of what we're bringing down is less the pretty crystals, but mostly actually granitic and schist rock for crystal analysis. But that's sort of the typical picture here, my student hanging on to transmission belt and scrambling around between the individual prospects. The mining is artisanal. It's all hand cobbing of ore, and this is how this looks. And yes, they do run machinery. They drill wet, and all of this was brought up 3,000 meters up the mountain on a horse train in bits and pieces, and then the diesel compressor is reassembled and in flip-flops and safety helmet, as you can see, single jack drilling. Explosives is smuggled in from Kazakhstan, and off they go. And this is the result of by now more than 50 years of artisanal mining with large cavities. Huge accident rate. We made an estimate that over the course of the history of this deposit, thousands of miners worked at the locality, and every family we met has lost one or the other due to fatal accidents, either collapse, landslide, horse falls off the mountain, and on and on. So our estimate is actually that a unrecorded number of about 2,000 miners lost their life at the locality over the course of the history. And then there are pockets, and in these pockets you're diving in is an example. You see this the muscovite coating, and there's a lot of calcite. A lot of the calcite you never see at the Tucson or Denver show because they all systematically etch off all the calcite. So we were actually surprised about seeing so much calcite. And if you look carefully here in the back, there it is. Here's the desired treasure. Here's the Sheelite crystal, which my student pulled out. There is a great history about this. As I mentioned, overall, mining started very late in the history of China. It started the Republic of China. There were systematic explorations for, in fact, any form of base metal deposits in China didn't start systematically before the 50s. This is where, under Zhu Enlai, this deposit was first recognized. There was the first geologic field work in the area was with Soviet support, and then it was mined for quartz initially for industrial and radar applications. And the second phase was actually for beryl, and this was because of, even though the fairly faint blue aquamarine, it was explored for potential if the aquamarine is of adequate quality as an export, because when China opened, it had no foreign currencies. There was a systematic effort to actually bring the crystals out in the international market for dollars. So there was a brief period in which the government was involved before this stopped. And this is actually also how the first material from the locality was really an absolute showstopper at the Tucson show. In fact, then around 88, when people from this from the marketing company, actually from the Sichuan Bureau of Geology and Mining, did bring the first crystals to the Tucson show. And this is how they became internationally known. But nobody cared about these beryl. What people were blown away was the Sheelite, which was initially literally carried on as a byproduct. And you could buy phenomenal crystals at the time, now tens of thousands in market value for a kilogram price of 10 RMB at the time, from what some of the people tell me. And we're actually still researching a little bit the history on how these crystals became known. So underground workings, here's a typical association. You see the marble with quartz veins, and in these quartz veins, there are the cavities typically lined with muscovite. And in these cavities of variable size, and this is unfortunately, we're not there when, but this were brought to us from a miner in the evening, is sort of a significant size beryl, and they clean up beautiful. And this piece turned out in the amazing gem piece. So now here's the question now we were asking ourselves, and this is really, so why are we there? So the science question was really, we wanted to understand these tabular beryl. So what's the crystal structure? What is the crystal chemistry? And why are these crystals tabular? And they do stand out compared to other also tabular beryl. So normally, it's in this column of habit. From Colorado, I should show the aquamarine from Mount Antero. Significant localities are Mina Sharai, and also Thomas Range in Utah, where you have tabular crystals, but they are generally much smaller. And so there is no other locality where you have these massive size tabular crystals. And also, as you see in this picture, mostly clear, but then there are generations which are actually more towards aquamarine color. And that was our question, what this could cause. And this was also the students' thesis project. But there was literally very little known in terms of also just the chemical composition of these barrels. And so we were looking for the substitutions on the different lattice sites. And if this could give a clue, because it was speculated actually that it is related, that these crystals are different compared to those from other localities in their crystal chemistry. And that was really then the main questions we wanted to look into. So Beryl has in the end member an ideal stoichiometry, this formula. So it's this beryllium aluminum silicate. It's a ring silicate mineral, hexagonal symmetry. That's of course also true for the one from Xuebaoding. And the only thing what was known was that they appeared to be, in some earlier analysis, rich in sodium, and supposedly had more water on the crystal lattice. And we'll talk about this in a moment. And so this past work, and especially this little field work, so all the material you had was only what was essentially already cleaned and processed, and losing all the geologic context as the material was available on then from the miners or the mineral market. So we actually then set out to do a very systematic analysis, throwing in a bunch of different analytical techniques, notably from my interest, also optical spectroscopies to go after this problem. And so the crystal habit, as I said, is almost exclusively these tabular habits in a very consistent form, where the crystals are really flattened in the crystallographic z-axis, and there's this large preference of growing radially. Very rarely do you see a hint of some columnar habit, and then you actually see that on the face there is this large density of screwless locations. So this is really more the outlier. Here in an albite matrix, most of the time you see it in this form. So then what we do is, as you do in mineral analysis, and so maybe this gives a little bit of flavor here for everyone, you put the mountain under the microscope, right? And that's sort of the learning experience also for my students. And so what we do is that we don't actually take necessarily the large gem crystals. What you want is actually, you want Sheelite and Cassiterite and Beryl, as you analyze it, then in a host setting. And so here's a representation of then a small veinlet embedded in the schist, the muscovite, the Sheelite, and here zooming into this image, this butterfly here under polarized microscopy is actually the Beryl. You see zoning. This is a result of different generation of growth, and then you analyze and look for chemical composition and substitution. And so what we discover, really, I'm giving this here in a nutshell, and for the less science inclined here, maybe take a nap here for a second, that the beryllium is substituted by lithium, and this to actually a significant extent. And the other substitution vector is actually the substitution of the aluminum with iron, but there is only a very small contribution from this channel. So the main case is actually that we have the lithium substitution for beryllium, and then it is sodium which charge balances this lithium substitution, because lithium is 1+, right? So if you take a beryllium 2+ out, you need to put another alkali in. And these alkali, the sodium actually sits, and this is a very unique feature in Beryl, and this is also why I got fascinated about this in these ring silicates. There's a vacancy site, which is in pure Beryl not occupied, but it's these vacancy sites and these channel sites where you can actually then place the sodium. This is why you can do substitution of a wide range. And what's even more fascinating is that you have space for water molecules. You can put in water, and this water is actually stabilized through this presence of the sodium, because it's very polar, that you can actually place water on these crystal lattice sites in Beryl. And therefore, we also study then in vibrational spectroscopy the water and then the spatial variation of the water. So we really study structural aspects of Beryl down to the molecular scale. And there is actually, that ties in all in my other interests, there is really interesting quantum physical properties associated with water molecules in these isolated pockets. But the bottom line, and really giving you just a bit of summary of the result of the work, was that you're finding similar tabular habit throughout the deposit. So this suggests that we have very similar and stable conditions during the crystallization in the whole system. And this was one open question also, because we're seeing a lot of Greisen type alteration, but apparently during the phase of these beryllium, tungsten, and tin deposition, then there were very stable crystallization conditions. And this is why you find this consistency. So we find very low iron and magnesium, and this is in fact then consistent that the entire system is low in iron. So there's very minor pyrite, for example, and this gives indication about the sourcing fluid. There are some different generations in the Beryl, and so this suggests that there may be some metasomatic replacement. In fact, with a decrease of this iron and magnesium, yet associated with an increase in sodium. And so this actually indicates an evolution and fractionation of the fluid in its late stage. And so therefore we derive, in fact, that the aquamarine, which you do see occasionally, is actually early in the crystallization sequence, and then the goshenite comes late. And so overall, that means that we have, in fact, a hydrothermal origin of the whole system, and it's derived from a very highly fractionated alkali perluminous lithium fluorine enriched albite S-type leucogranite. And this actually is another topic then where we were interested in what the hosting, what the source of the fluids is. But the key summary then for these tabular habits is that it's unlikely related really to a chemical composition question or the alkali content. This has been a persistent hypothesis, but lacked any evidence. But at the same time, really, and this is not unusual, when you have crystals of different habit, you don't necessarily know the factors that control the crystal habit. And this is true for this and other localities, really. So that then brings me really sort of to the second topic, and this is why are we there again? So we actually continue to visit the locality, and then we kept on chasing another mystery closely associated with the theme of the symposium, and this is now the crystal habit of Sheelite. And so when you go to Tucson or Denver or just on eBay and look for Sheelite and Xuebaoding, then you find offers for these types of Sheelites. So they are regular, pseudo, octahedral, and always or typically on a muscovite matrix. And if not, you often see a little bit of muscovite flake grown into onto the Sheelite. They always grow in this association. But then occasionally you may get across Sheelites which look like this. And they're also offered sort of under the same generic label of Sheelite from Xuebaoding, Pingwu, Huya, Minyang, random names of towns or cities over a large area. And so we were always puzzled about whether, and they are not on a muscovite matrix, they're directly grown on a highly altered felsic rock. And so we were wondering about what that is and where that's from, and whether this is truly from the same locality or whether they're actually different localities. And the challenge already starts that a lot of the local miners are very uneducated. They don't even use the term Sheelite. So if you ask them about a rock, where it's coming from, this one here runs under rooster bloodstone, actually, is the terminology. So don't come even with the Chinese technical term for Sheelite, which is Baihuang, and you have to actually. And so I was prepared. I pulled a lot of aerial aerial photographs, pulled the geologic maps, and we were wondering where could be in this whole area be other localities. And Xuebaoding is over here. There's some granitic intrusion, which could be sourcing the fluid. And then on some large-scale geologic map, there was some granitic intrusions shown in this general area, actually around the town of Ping. And so then I pulled pictures there, and it's always hard to distinguish what's a landslide and what's a former prospect, and if there's anything. And so then we went in the field. And so what we did is we drove around. We drove into every of these little small villages. And then my student here, equipped with the maps I prepared for her, was then talking to all these locals. I speak some Chinese, but I understand nothing of, not Sichuan dialect is one level, but even these local variations of these local different dialect variations were sometimes even a challenge for my student who grew up in some of these areas. So we went to these towns and talked to the people, and lo and behold, then they tell us, yeah, there were localities. Oh, it was right there. And so, yeah, we gave up on this. It wasn't very big, but there came out these beautiful Sheelites. And that was great. We need to go there. We need to... And so we did on multiple trips, you know, and these are all local farmers who at different times mine these localities. It's much lower down, which makes it much harder. You're in insane brush. A lot of things remind you of the Pacific Northwest. This is the tool of the trade with which you're working your way through it. And all my satellite imagery was, of course, off because the localities have since been overgrown. The last active mining on these smaller, more dispersed localities was all actually in the 90s. They are in a different geologic setting, but we were still wanting to chase down the origin of where these other Sheelites come from. And it's actually in part on purpose because this is illegal for the local farmers to collect minerals or mine. In fact, all the natural resources in China are technically all government owned. And so this is all a hush hush and under the counter. And this is why I'm not showing any close-ups of some of the people who were helping us in the process. So we're finding the locality. There it is. Here's a quartz vein, very different setting, different alteration. It's a highly altered marble schist where the quartz intruded, and in these quartz veins is where the Sheelite occurs, often then grown not in the quartz but on this wall rock. And these localities have since been abandoned. And then here is my student sampling, and we're going in the mine. This often caused a little laughter because this was shortly before the COVID hit in the workings, and it's a very complex stockwork of veins, and that's where we were going after the Sheelite. Here's the Sheelite is rock forming. It's very rich, and here are sort of the types of crystals. So it's always, or if associated with anything, it's with quartz. There's no beryl, there's no cassiterite, there's no muscovite whatsoever. So it's only minor apatite. Here's the apatite crystal. This was only recognized later through our analysis on this schist altered marble wall rock. The localities are on the order of 20. They are spread over a much larger area than this more confined Xuebaoding mineralization. And we did not see a direct association with the source fluid. So this is probably one of these deeper seated granite intrusions which crop out, but not necessarily associated with this. So this was then the second mystery about that. If you do see material in collections or have some yourself, this characteristic dark red, with these associations is from these other localities. So this mystery has been solved, and we're actually writing an article also on this topic. So why are we still there? Maybe just because I'm just drawn into the mountains and back into this locality. but there are still open questions. Where do the mineralized fluids come from? And so I continue to visit. It's often associated with other reasons why I go to China as part of my primary research collaborations. And I was there in 2021. Now you say, what? 2021? This was COVID. You were in China. Well, here's the deal. So COVID, as you know, broke in Wuhan and spread rapidly. And of course, this is where China was the hotbed. Then this is the data from February 2020. But then for a period last year, also before the vaccine became available, we had a complete inversion of the situation. So a year later, because China walled themselves in, I think they're pretty good in doing this. They still do. China had very low COVID, and this was still through the early strands. And if you were able to make it into China, you could actually travel fairly freely. And there were very little restrictions within China, but it was very hard to get in. And so I still have to appointments in Shanghai. I still have a visa, and I managed actually, in fact, through Germany because of limited flights from the US. And after 2 weeks hotel quarantine and 5 PCR tests later, I was actually able to travel. And so starting out in Shanghai, I actually paid a visit to Wuhan. This is the famous market. I was actually there 2 weeks after the World Health Organization, and then off to Xuebaoding in this area. What are we looking for? What we're looking for is now the question more about the granite. So where does this mineralized fluid come from? What's really the petrogenesis in the system? So the general idea is that we have this granitic intrusion, and it provides the fluid, and then through deformation of these schist and marble layers into which it intrudes, that it forms the conduits and then the crystallization in veins in the marble and schist. But a lot of details were not clear. In the meantime, we published a bit on details of this on some of the granitic analysis. We did isotope analysis, which actually indicated that we have a S-type leucogranite, which we believe came from a metasedimentary source, upper crustal. We could show this high degree of fractionation. This is a requirement, of course, for that you get this type of deposit. And we looked into some details again about if you look at the mineral association, in fact, you do see this high enrichment in these key elements of tungsten, tin, and beryllium associated with some of these alkali. And the calcium is sourced from the marble or the calcitic schist. And this is what's needed for forming the Sheelite. There is a good amount of fluoride. Some of you may know the famous apatite. And then, as we saw in the field, this large amount of calcite, which never makes it down the mountain. And so this actually suggested some fluid immiscibility, which facilitated the formation of the crystals. And that's why we also get very little alteration and then this very high crystal quality. But what we wanted to look at then was not just studying granite really in contact and this highly altered granite in sort of a Greisen. We wanted to look at the deeper seated granite. So how do you actually get down into the core of this granite? Well, you can core drill down for about 2 kilometers, or thanks to the erosion features, then you can actually go into some of these steeply cut canyons, which penetrate over this mountain, which are literally 2 kilometers deep below the deposit. So up in the fog here, I think I mentioned fog and rain already ample. This is actually where we are at the top, and this is where the deposit is. And I wanted a granite sample 2 kilometers below in this face. These mountain faces, they absolutely rival anything you've seen in Yosemite. This is just unbelievable. And so I want to look for unaltered granite down there. So now we do this in the winter, and I'll tell you in a second why. So we're starting out. Here's now the detritus you see from the COVID. And what we need to do is we need to go up some of these canyons. And this is not, you can't go through the brush. This is impenetrable, especially if you need to go 20 kilometers upstream. So you could only follow the riverbed. And this is me crossing, and this is how the water level is in the winter. In the winter, the Tibetan Plateau is dry, so the runoff is lower. This is the summer water level. And this is why there's wall to wall. You cannot readily get to where at least we wanted to go. So you're working your way up. You can't always avoid the brush. You are rained on with ticks and leeches. That's also an exciting experience in the bamboo forest. It was just low enough that we could do it. It's completely dry, upper, high. We keep going. Here's our wall. The deposit is up high. And there is a granite. That's what we're looking for. We see the float, but we want to go outcrop. Beautiful. Snow, outcrop. Finally, 20 kilometers in of this canyon, we're getting granite. There it is. And this is the ongoing project right now. We are looking at now the unaltered granite, not in direct contact with the top-seeded deposit. And of course, everybody in China called me crazy. They understand when I always said, oh, I want to go to locality and the crystal deposit and all that. That was understandable. It was much harder to convince people to say that I'm going for a multi-day trip just for a few handful of granite. But there it is. Here are all the friends who helped me in the process. And there are more. And I think with that, I'd like to thank you for your attention, and I hope you enjoyed this, and I'm happy to take questions, and promise the next symposium I'll be there in person, and look forward to seeing all of you. Thank you.
Question is, does the Sheelite fluoresce different from that location than other locations in China?
Yeah, so I can give another half-hour talk on the Sheelite. So the Sheelite, many ways, actually Sheelite fluorescence. And it's due to the rare earth dopants, and it's generally still a white blue. And you would really need to do often the visual appearance when you come in with broadband UV. Doesn't really tell you that much. That's actually something we wanted to do, to look more and look at the crystal chemistry of the Sheelite. The composition is already known, but it's a fascinating topic itself because of the mechanism of the Sheelite, especially from the rare earth dopant fluorescence.
Okay, any other questions? Okay, so 2 questions. First question is, what is the status of the granite samples that you brought back? What's going on with those? And the other question is, any clues on the tabular barrels and why that was formed?
Yeah. So I have to actually also say that I'm not the expert igneous and ore petrologist. Yeah, so my component is a lot in the field work and IR and Raman spectroscopy. But the main goal is that we did analyze the granite bore in contact where the last phase and concentration of the ore forming fluid came, and this is where the granite is highly altered. There is limitations in what we could draw from. We did strontium, neodymium, lead isotope analysis. We did a whole rock analysis, look at zircon hafnium ratios, and then the whole rock analysis to see about the enrichment in the tungsten and the tin and so forth. And so there's only so much we could draw in terms of conclusion from that. So this is why we want to compare that with the deeper seated granite, and that should narrow that question. And the other about the barrel, so the crystal habit in this case, there are different surface free energies of the different crystal faces, and then at particular pressure and temperature conditions and evolution, you may get conditions in which one phase grows faster than the other. This is, but there is not enough known really to be conclusive on this, because the whole free energy landscape and thermodynamics of the barrel is apparently, as far as I was told, and also not studied enough that one could not really conclude. So we try to narrow, of course, these conditions. It's a fairly low temperature crystallization system, and what you need to do to sort of, under what conditions the crystals will grow in this form. I think is not known, and in general not known also from any of the other localities. The other clear beryl from Mineralogy, I think there is also no clear answer. And I have to also confess, I would not know really how one could systematically narrow that.
Question is about labeling. All of the tabular beryls on Mindat are labeled Pingwu tabular mine, beryl mine. Would you agree with that?
No, this is absolutely wrong. And let me maybe I'll show again this map about and why this misnomer. So the reason for this misnomer and all that has two reasons. One is that given the actual within China, and there are people in prison, local miners who did get caught. So this is really a very even in China, highly illegal mining activity, which the government is increasingly cracking down on, in part also because they develop this now more and more into tourist localities in the vicinity. So the key town is Chengdu. There is Pingwu. Pingwu is this town here on the east side of the Huya Fault. The Huya Fault is a major separation of different geologies here, and here's the Xuebaoding, and this is this mining town associated with this name Huya. So it's Huya is the town below the mountain Xuebaoding, and so a lot of the mineral specimen go through Pingwu, and from there Minyang and Chengdu out of in the mineral market, and so. In order to actually sort of be not too specific about the origin, this is why often they are generically labeled as Pingwu. Yeah? But the beryl comes with absolute certainty actually from Xuebaoding, because in these other occurrences with the Sheelite, which is concentrated in an area north of Pingwu, these red dark Sheelites with these different habits. They are from this area. There is no beryl associated with it. So you can safely relabel all of your beryl specimen as Xuebaoding proper, including all the Sheelite and all the Cassiterite, except the Sheelites, which are with this different habit, the darker red examples. They are from these different smaller deposits north of Pingwu. So that's where you can put your Pingwu label on.
So, Marcus, it's a comment about the photograph that is used to illustrate Pingwu there. Can you describe what we're looking at there, what that green is, and confirm the elevation?
Yeah, elevation positively confirmed. It is that low. And this is one of the rivers, the Minjiang, which goes through. You have surprisingly large rivers up in some of these very deeply cut valleys, and that's because you have this enormous precipitation and this enormous runoff. So this fertilizes all of East China. This all goes into Yangtze. This all produced the fertile land east. Is all this sediment deposit which washes down from this area. This is an area which is the largest vertical relief. And what is also fascinating, and a lot of it relates to Pacific Northwest aspects, that, for example, also in Konga, you have this is also worldwide one of the youngest granitic pluton exposed because of this enormous erosion rate, that there is granite as young as, I think, recent dating was even younger ones. But yes, so if you do a cross-section from the Sichuan Basin, here, and where Pingwu sits kind of a little higher in some of these deep valleys, to Konga, these lateral distances this is literally only some aerial distance of 20 kilometers. Yes, it is that impressive.
Marcus, it looks like that's it. Thank you again so much for your presentation and hanging around afterwards to answer some of the questions.
Absolutely. Any follow-up, just anybody shout out to me. They know how to reach me. So very good. Yeah, thank you.